So we are talking a little bit more about series, what that means, in terms of a cumulative total. So in our previous lessons throughout this unit, we have most likely done a little bit with looking at a running total, possibly in a spreadsheet, and the idea that when you add up terms rather than listing them, so keep in mind that listing is a sequence, okay? So when you add them all up, adding them up, that creates what we call a series, okay? So when you add up a specific set of terms, we call that a series. That term is basically to help indicate that, hey, I didn't just write out a list, I actually took all the numbers and added them up. Now, some series might require that we substitute in values to add up the terms. Some have formulas. So it kind of depends on the situation. But first, let's consider some new notation called sigma notation. Okay, now you may know that word by some other like cool, fun slang term. But sigma is just the name for this symbol, this fancy E, and it means that you are supposed to find the sum of whatever explicit formula you've been given, okay? So if you'll notice, this notation right here that I'm going to highlight in green, so that part is telling us that we want to find the sum of terms 1 through 5, and then over here, this is saying using this explicit formula, okay? So basically what I'm going to do is I'm going to substitute in 1, 2, 3, 4, 5, and I'm going to write them on these little lines, and then I'm going to add up what that total is. So I'm going to have 1 squared, which is just 1. Okay, so hopefully you kind of see that. So 1, and then I'm going to have 2 squared goes here, so that's 4. And then I'm going to have 3 squared, which is 9. And then I'm going to have 4 squared going here, which is 16. And then I'm going to have 5 squared, which is 25. And so I'm going to add up all those numbers, all right? And so I'm going to get out my handy-dandy calculator, right? I'm going to add 1 plus 4 plus 9 plus 16 plus 25, all right? And that sum is 55. Okay, now that's the total. So we would say that that is S of the first 5 terms is 55. Okay, I'm going to do one more with you, and then I'm going to let you guys kind of try a couple. So again, this is saying find the sum of terms 1 through 4. Oh, and by the way, if you're like, wait, how do you know that? I should point out it's because we're starting at 1 on the bottom and we're ending at 4 on the top. That's what those numbers at the bottom and the top mean. So it means I'm going to plug in 1, I'm going to plug in 2, I'm going to plug in 3, and I'm going to plug in 4. And then I'm going to plug each of those numbers into this formula, right? I'm going to use that one. So it's going to be like 2 times 1 plus 3, 2 times 2 plus 3, 2 times 3 plus 3, 2 times 4 plus 3. So we're going to get 5. 7, 9, and 11. All right? And then I'm going to add all those up. So it looks like that's going to be, and again, you can use your calculator or you can use your noggin. 5, 7, 9, 11, 32. All right? And now we say then that S32, S for sum, sorry, S of 4 is 32. The sum of the first 4 terms is 32. Okay, so I would like you guys to take a moment and try number 3 on your own. So without my help, try number 3. Pause the video, and then when you come back, you can see if you're right. Okay, welcome back. Hopefully you started at 2. So you got 6, and then you got 9, and then you got 12, and then you got 15, And then you got, let's see, what are we at? 2, 3, 4, 5. We're at 6. So 18. And then 21, which is where you stopped. And then hopefully you got the total. 6 plus 9 plus 12, 15 plus 18 plus 21. 2, 3, 4, 5, 6, 7. Yep. 81. And so remember that S of, and I guess we would say the sum of the n terms that we added up, because we didn't start at 1, is 81. Okay, examples 2 and 3 above are actually something we've already talked about. They're called arithmetic sequences. So if you'll notice, the an in number 2 is 2n plus 3, and the an in number 3 is 3i. Those are both explicit formulas. And as a reminder, an arithmetic sequence is a sequence or list of terms with a common difference between each value. Okay, so basically that means that there is an adding or subtracting pattern, a constant value. All right? An arithmetic series is the same idea. The only difference is that when we say series, you're going to add all the terms together rather than just listing them out. So it's kind of like you're taking things one step further. You're going to list out all the terms, and then you are going to add them up. Okay? Now, there is a very famous story about this guy named Gauss trying to figure out a shortcut for finding the value of an arithmetic series. The finding that this person made doesn't just apply to adding 1 to 100. It applies when you're adding any sort of term. Okay, so to kind of illustrate what I'm talking about, let me first point out that you could certainly just brute force add up any number of numbers, okay? But your time is valuable, right? Everybody's time is valuable. So there has to be a more efficient way to add up numbers if they follow a consistent pattern. So here's what I'm going to do. I'm going to kind of rehash this story for you if you haven't heard it before. So the story involves you starting with the numbers 1, 2, 3, 4, etc. We're just like counting, okay? And so then eventually you would get to 97, you'd get to 98, you'd get to 99, and you'd get to 100, okay? And you'd add up all those numbers, all right? Well, there's something that we should notice about the first and the last number, all right? So if I look at those two numbers, and I add those up, so that's A1 plus AN. They are 101, all right? Now, if I take the second to the last number, so A2 plus AN minus 1, that is also 101, all right? And then if I take this third set of numbers, so that'd be A3 plus AN minus 2, that is also 101, all right? That's going to keep happening all the way until, I want you to think about this, in the middle, the two numbers would be 50 and 51. And they also add up to 101, okay? So that same idea would be true here. 1 plus 1,000 is 1,001. 2 plus 99, 2 plus 999 is 1,001, right? And the number that would be, right here would be 998. And if you add these together, we'd get 1,001. Okay, so the situation in both of these cases is that because I'm combining two terms, I'm only going to have half the terms to add together, all right? And they're all going to be the same number. So I could take the fact that this is the thousandth number. All right, so 1,000. Divide that by 2. Because when I add these all up, I'm now going to have half as many values to add. And I'm just going to multiply it by 1,001. And that would be my total. Okay, so that's 500. Sorry, I was going to do that on my handheld calculator and realize that I wanted to show it to you. That would be 5,000 times 1,001. So it would be this number, 500,500. Ooh, sorry, guys. Went to the wrong screen. So 500,500. All right? Now, what if we wanted to do that here? Okay, now this gets a little bit tricky, okay, because I'm not quite sure where 103 is. I know I'm starting with 5. All right, so let's see. 5 plus 103, that's 108. 6 plus 102, that's still 108, right? 7 plus 101, okay, that's 108. So at least we know that the thing we need is 108. But the question is, how many numbers are there between 103 and 5? Okay, well, if 103 is A103, and if 5 is A1, okay, there would be 103, there'd be, sorry, that's A1. Yeah, 103. There would be 102 numbers in between them, right? A 102 numbers in between, right? 102 positions. So we would need to take 102 divided by 2 and times it by 108. So we'd get 51 times 108, which would give us 5,508. Okay, so hopefully you're kind of getting that idea. But let's look at a much simpler version just to help us out. So this is A1, and this is A 2, 3, 4, 5, 6, 7, 8, 9, 10. A10, okay? So we have a grand total of 10 numbers that we are adding up, right? We know that A1 is 4, and we know that A10 is 31. And if you look, 4 and 31, that's 35. 7 and 28, 35. So first off, you could just break this down, 35, into smaller groups, right? 35, and then these two added together would give me 35. So we know we have 5 groups of 35. So that's 5 times 35, which is 175, okay? So how does this translate? How can we apply this to any sort of formula? Well, let's take a look. If I take the fact that 5 is 10 cut in half, and the fact that the 35 comes from taking the first number and the last number, right, in this case, A10, I can then make a formula for any. So how can we apply this? As long as we find using A1, AN, and N, the number of terms, we can say that the SN for an arithmetic would be N divided by 2 times A1 plus AN, all right? And this formula will be helpful to us anytime we want to add together an arithmetic series, all right? Now, if you're wondering if there's a formula for a geometric, there totally is, and that is going to be in our next video. So thanks for listening so far.